Okay, Assalamualaikum warahmatullahi wabarakatuh. Hello, let me introduce myself. My name is Vinna Shakyla from class numerical method 03. So in these videos, I will explain and present about optimization. Okay, next. Okay, first, what is optimization? So optimization is the process of making something as effective, perfect, or functional as possible in the context of mathematics, computer science, and the operation research. And optimization refers to the selection of the best element from set of available alternatives. So if we want to making something an engine is, for example, to be a bit more excellent and alternatives can use optimization to make it more to another level. Okay, next. So, in the more general approach, optimization problem is actually consists of maximizing or minimizing a real function by systematically choosing and input values from within. So in here, I want to explain also about the key concept in optimization. There's for the first is objective function. So this is the function that needs to be minimized or maximized. For example, in a business context, it could be a cost function, minimization, or a profit function, which is that is maximization. And the second one is constraint. So there are restrictions or limitation on the variables. Constraints can be equality constraints. So there's an example for it. For example, x plus y equal to 10, or an equality constraint. For example, x min y is furthermore equal to 5. So this is the example of the formula or equality and equality. Sorry. Okay, third is variable. So there are the inputs to the objective function that we can control or adjust in optimization process. We aim to find the optimal values of these variables. Okay, next four is visible occasion. So this is the set of possible values of the variables that satisfy the constraints, and the optimal solution must lie within this region. So also optimization have an application in real life. For example, the first one is in engineering, design of structure, control system, and manufacturing process. In economics, for example, is resource allocation, production planning, and portfolio optimization. For operation research, scheduling, logistics, and supply chain management. Fourth is machine learning. It is training models by minimizing error functions or maximizing likelihood function. And the last one is finance, risk management, option pricing, and advancement strategies. So this is, I want to give some example application optimization in engineering. So we need to find the dimension, length, width, and height of rectangular box that maximizes the volume while keeping the surface area below a specified limit 10 square units. It uses numerical optimization method to achieve this goal. So I will give you some example. There is a code of the Python for maximize or optimize the question. So here the program, what I'm gonna explain the program and I will break down the program but one by one. So in here we have library, importing libraries such as import numpy as np and from scipy.optimize import minimize. So in numpy, it means we need to use numpy for numerical operations, and scipy optimize minimize it we need to use for performing the optimization. So after that, after we know about the importing libraries, now we will go to the defining function. So we need volume calculation. The function calculates the volume of a box given if its dimension, such as like line, width, height, and volume. And the volume is have a formula that is line times width and times height, and we can return a volume. So we need to calculation the surface area, and this is the surface area. The function calculate is surface on the box. The formula is 2 times line times width plus 2 times line and times height plus 2 times height and times width. So next we go to objective function. So this function defines the objective of the optimization, which is to maximize the volume. Since the minimize function minimizes by default and the negative of the volume is used to effectively perform maximization. Next, we go to constraint function. So this function is defines the constraint for the optimization, ensuring that the surface area doesn't exceed 10 square units. So, when the question is posed to lower than 10 square units. Next, setting up the constraint. So this is the formula. Here the constraint is defined as inequality, meaning the constraint function should be non-negative, and this ensures that the surface area is less than or equal to 10. Next step is we need to initial the guess. An initial guess, the dimension of the box is provided. So this is the starting point for the optimization algorithm. And then we need to move to performing algo optimization. So the minimize function is called with the objective function, initial guess, optimization method, and the constraint. So the option argument ensure that the optimization process details are displayed. Next, we extracting and displaying the result. So we can try to run the program. Well, it's take a long, pretty long time. So yeah, this is the result. The optimal dimension found by the optimization. Uh, so the optimal length is this uh this number, and the optimal width, height, and volume and surface area. The optimal volume, which is the negative of the minimum object function value, and the surface area of the box with the optimal dimension, and the program prints optimal dimension or corresponding volume and the surface area. So objective maximize the volume of the box, and the constraint means surface area of the box should not exceed 10 square units, and the method is used to handle the box objective constraint efficiently. So we have got the number, the result. So I have a conclusion. By running this program, we will obtain the dimensions of a box that maximize the volume while the ensuring the surface area is within the specific limits. Okay, so I think this is all from me. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.